Hello student, welcome to all of you in the next physics lecture. This is the video number 21. Myself Rajesh Lagar, physics teacher. Now we have to see the second chapter, mechanical properties of fluids. In this chapter we have to see the next point, and this is nothing but the fluids in motion, in which we see the different points: steady flow, streamline flow, then turbulent flow. These terms we have to see in that session. And in your exam, you have to ask sometimes, what is the distinguish between the streamline flow and the turbulent flow? Then we have to clear here the fluids motion, the branch of physics in which deals with the study of properties of fluids in motion, which is called as a hydrodynamics, and the study of motion of a real fluid, which is the very complicated, and there are some limits for our study to the motion of the ideal fluid. Now here we have to discuss the different types of the flow. So what is meant by the steady flow? This is the measurable property such as the pressure or the velocity of the fluid at a given point. It should be constant, which is called as a steady flow. Then what is the streamline flow? The streamline flow is also called as a laminar flow. It is a steady flow in which the adjacent layer of the fluid which moves smoothly, and in which the fluid it moves smoothly over each other, and sometimes its velocity with the smaller than a certain critical velocity, which is called as the streamline flow. Then there is also another turbulent flow. It is a flow which is at the very high flow rate, so that there is no steady flow, and the flow pattern changes continuously, and which is nothing but a turbulent flow. For example of the streamline flow, the streamline flow, the identical flow or steady flow, in which a steady flow of river, which can be assumed that a laminar flow, and a flooded river flow or the tap running very fast, which is nothing but a turbulent flow. That means in turbulent the velocity is not constant, and streamline flow the velocity remains constant. And so that we have to distinguish here the streamline flow and the turbulent flow. Then there are the four important points in between this streamline flow and the turbulent flow. First point is the definition. Then we have to understand first in streamline flow, steady flow, smooth flow of the fluid, and the velocity which is smaller than a certain critical velocity, which is called as a streamline flow, or also known as a laminar flow. Then what is meant by the turbulent flow? Turbulent flow is a irregular flow, unsteady flow of fluid, in which the velocity increases beyond the critical velocity. That means critical velocity which is not constant, which is not steady, which is unsteady, the flow is irregular, and its velocity goes on increases beyond the critical velocity, which is known as a turbulent flow. And streamline flow is a smooth flow with the velocity is smaller than a certain critical velocity, which is called as a streamline flow or the laminar flow. This is the very important distinguish between the streamline and the turbulent flow. Then second distinguish between them is nothing but in streamline flow the velocity of fluid at any given point is always constant. Streamline flow, the velocity of fluid at any given point is always constant. And in turbulent flow, the velocity of fluid at any point does not remain constant. In turbulent flow, because it is unsteady, it is irregular, so that its velocity does not remain constant. Third one is that the two streamlines flow, they cannot never intersect with each other. They can never intersect with each other. That means they are just parallel with each other. And turbulent flow, at some points, the fluid may have the rotational motion. They convert into the ED. That means they are the random. They are not in a steady. The points at some, they may have the rotational motion. And in this way, they are not parallel with each other because they move along with the rotational motion. This is the third one. And last one, fourth one distinguished is nothing but that the streamline flow over a plane surface can be assumed to be divided into a number of plane layers. Streamline flow over the plane surface assumed which can be divided into the number of plane layers. And turbulent flow, the flow of tube loses its order and particles moves in a random direction. They wander here and there. Therefore, the flow of tube loses its order and their particles moves in a randomly motion. This is the distinguish between the streamline flow and the turbulent flow. You asking this question in exam, then each distinguish is nothing but the half mass. This question asking for the 2 mass. What is the distinguish between streamline flow and turbulent flow? Then we have to see the next point is nothing but the critical velocity. Define the critical velocity. What is the formula for this critical velocity? And the Reynolds number. From this we can find out this critical velocity. Then critical velocity is nothing but what? The velocity beyond which the streamline flow becomes turbulent flow is called as a critical velocity. This is the very simple sentence. Critical velocity, the velocity beyond which the streamline flow becomes turbulent flow. That means steady flow convert into the unsteady, regular flow convert into the irregular. At that velocity beyond which the streamline flow becomes the turbulent flow is called as a critical velocity. According to the Reynolds, the name of the scientist Reynolds, who has given this critical velocity, and which is nothing but the Vc is equal to Rn into eta upon rho into d. Vc is equal to Rn into rho upon rho into d, where Vc is the critical velocity of that fluid, Rn is the Reynolds number, this is the scientist name, eta is the coefficient of viscosity, we have to next point is the coefficient of viscosity, we have to see next. Rho is the density of the fluid and d is the diameter of the tube. Then Reynolds number, from this equation critical velocity we can find out this Reynolds number in such a way that Rn is equal to, take this rho and d's denominator multiply by this numerator Vc, therefore Rn is equal to Vc into rho into d and upon eta. Reynolds number Rn is equal to Vc into rho into d upon eta, where eta is the coefficient of viscosity. And this Rn, that is the Reynolds number, which is the pure number, and so that it has no unit and no dimension. Experimentally it is found that if this Reynolds number Rn, if we found that which is the less than 1000, because it is a pure number and we have to find out this Reynolds number, and which is less than 1000, then the flow of fluid is a streamline. Then the streamline flow is, then this flow of fluid is a streamline. When this Reynolds number is less than 1000. If you have to find out this Reynolds number which is greater than 2000, then the flow of fluid is turbulent. Less than 1000, streamline flow. Greater than 2000, then it is turbulent flow. And if this Reynolds number Rn, which is lies in between the 1000 to 2000, then this flow of fluid becomes unsteady. That means it changes from streamline flow to a turbulent flow. This is nothing but the Reynolds number. Okay, if you have to understand this well. Then the next term is the viscosity. We have to clear here. This Vc is the critical velocity. Give the definition that Rn is the Reynolds number, then rho is the density, d is the diameter, and eta is the coefficient of viscosity. Then first we have to see that what is meant by the viscosity. Then we have to see the coefficient of viscosity. In this viscosity, Suppose we give the some example. When we pour the water from a glass, it flows freely and quickly. If you have to take the example for water, which can be pour the water from glass, then it is very freely and quickly. But when instead of water we have to take any syrup or the honey, then we pour the syrup or honey, then it flows slowly and stick to the container that pots inside that honey or the this syrup, which can be a stick inside the container. Then the difference is due to the fluid of friction, and this friction is the both within the fluid itself, between this fluid and the surroundings. And this property of fluid, which is called as a viscosity, this property is known as a viscosity. Then we have to define this viscosity. The viscosity is nothing but it is the property of fluid by the virtue of which the relative motion in between the different layers of fluid experiences a dragging force. You have to see here the dragging force. What is meant by the dragging force? Viscosity is that property of fluid by the virtue of which the relative motion in between the different layers of the fluid which experiences a dragging force. We have to see here this property in such a way that which can be gives the relative motion in between the different layers. That layers are nothing but the we have to consider here the stationary layer, then the v plus dv, v and the v minus dv on the stationary layer from the, and the distance is nothing but the x minus dx, x and x plus dx. Then from this we have to define here the velocity gradient, and this velocity gradient is nothing but the rate of change of velocity dv with respective distance dx, and measured from the stationary layer, which is called as a velocity gradient. And this velocity gradient is nothing but a dv upon dx. Velocity gradient is nothing but the dv upon dx. That means this is nothing but the rate of change of velocity with respect to a distance measured from the stationary layer, which is called as a velocity gradient. Then velocity, you know that, which is measured in meter per second, distance is measured in meter, then velocity gradient is measured in per second. Then we have to also find out the dimension. We know that the dimension of the velocity L1 m0 t minus 1, and distance is nothing but the L1 get cancelled, only t raised to minus 1. In this way we can find out the unit and dimension of this velocity gradient. Then in this topic we have to see the very important points. What is the distinguish between the streamline flow and turbulent flow? Then next point is the critical velocity. From this we can find out the Reynolds number. You have to ask something. This Reynolds number we see rho into d upon eta, and critical velocity we see is nothing but Rn into eta upon rho into t. And from this also we have to next property of the fluid is the viscosity, and also we have to see the velocity gradient. This is very important, and if asked for the short question, you can be the understand well. Okay, thank you.